There was a time when Earth did not operate as we know it today. A world in which even the atmosphere felt heavier, denser, almost tangible as you breathed it in. From about 359 to 299 million years ago, long before dinosaurs appeared or any familiar forms of life set foot on land, the planet entered a completely different state known as the Carboniferous Period. Under those conditions, swamp forests not only survived, but exploded in growth. Vegetation grew so densely and spread so widely that it almost swallowed sunlight itself, creating a world where the ground was perpetually submerged in damp shadow. While plant life followed a constant cycle of death, decay, and accumulation, as fallen trees were buried faster than they could decompose, forming layers of organic material that extended over millions of years. Meanwhile, water seeped everywhere through root systems and low-lying basins, turning the entire ground into a soft, unstable mass that was always slowly shifting beneath one's feet, as if the planet itself were breathing under that vast blanket of mud. And within that seemingly still environment, if you observed long enough, you would begin to realize that it was not only the landscape that was changing, but even the scale of life itself was being stretched in an unusual way. Because in that oxygen-rich, nearly saturated humidity atmosphere, life did not develop in a stable direction, but began to expand generation by generation without a clear limit. Especially insects and arthropods, organisms that directly depended on oxygen for respiration, where each new generation absorbed more energy from the same environment, causing their bodies to gradually expand beyond familiar limits. At first, these were only subtle deviations, barely noticeable among layers of decaying leaves and shadows. But over time, these deviations accumulated into clear differences. Eventually, on the damp forest floor, long segmented bodies began to appear, moving through the decaying vegetation as a natural part of the landscape. While above, oversized wings started to occupy the airspace between dense tree trunks, adapting to the thick atmosphere that allowed them to fly without expending as much energy. What mattered most was not individual species changing in isolation, but the entire ecosystem being pulled into a new state. But became a fundamental rule of life, making every movement in the Carboniferous forest feel as if it existed within a world magnified from ordinary biological principles. The clearest aspect of this mechanism lies in the carbon cycle. Vast swamp forests functioned as a natural carbon sequestration system, where organic matter was buried faster than it could decompose, causing oxygen to accumulate in the atmosphere to unusually high levels. This state, in turn, created a less noticeable effect. Biological energy was no longer distributed evenly, but began to accumulate and concentrate within the system over time. At that point, biology was no longer developing linearly. It began to amplify, and it was precisely at this point of amplification that life forms such as Arthropleura became possible. Not in the sense that they suddenly appeared, but in the sense that the environment had reached a threshold that allowed them to exist without being constrained by ordinary physiological limits. Arthropleura, with a body longer than 2 meters, moved through the wet mud like an extension of the terrain itself rather than a distinct individual. It was neither a predator nor an apex of the food chain, but a direct product of an ecosystem overloaded with decaying plant matter and so rich in oxygen that its energy exchange processes were no longer constrained as they are in the modern world. But what matters more is the way it interacts with the surrounding environment. Every movement of Arthropleura is not only a physical displacement, but also an impact on the muddy substrate, which is constantly in a state of minute oscillation. These oscillations do not disappear. Instead, they propagate into deeper ecological layers. Below the surface, where light no longer defines perception, another system begins to take over, where creatures such as Pulmonoscorpius exist entirely in a world of vibration rather than light. With sensory systems on its legs and abdomen, it does not see its environment, but reads it like a continuous signal network, where every slightest change in ground pressure carries information about movement above. While these signals travel downward into darkness, the same movement propagates upward into the forest canopy. As Arthropleura moves through dense forest areas, the canopy structure is disrupted in very small intervals, enough for light to filter down as discrete points rather than a continuous layer. These extremely subtle changes alter the behavior of insect populations in the space above the ground, causing organism density to no longer be evenly distributed, but to cluster into reactive groupings. And within those reactive clusters, Meganeura emerges as an adaptive variation of the system itself. With a wingspan of nearly 28 inches and the ability to fly in a high-oxygen atmosphere with unusually low energy expenditure, it does not move through space like a modern insect, but rather appears to drift within the dense air layers. From its elevated position, it does not observe the entire ecosystem, but instead locks onto very small deviations in the movement of insect swarms, below localized points of imbalance unintentionally created by the system. Once detected, it dives at speeds of about 18 to 25 miles per hour, generating a continuous predatory force that instantly reshapes the distribution patterns of populations in real time. This feedback loop does not stop in the air. As the ecosystem extends into the transitional zone between land and water, where the boundary between the two environments becomes blurred, similar mechanisms continue to repeat in another form. Hibbertopterus, with its slow, sweeping mode of movement, interacts directly with the sediment layer on the seabed, removing small organisms and reshaping the biological structure of the area it passes through. Beneath the murky water, Proterogyrinus functions as a final response mechanism, using vibrations to determine the timing of attacks from below, completing the chain of interactions across different spatial layers. In a modern perspective, what matters is no longer individual species on their own, but the way they collectively participate in a continuous feedback system, where land, air, and water do not exist as separate layers, but as information channels within a single interconnected ecosystem that is constantly self-regulating and self-amplifying. To see just how ruthless this system truly was, look at the point of intersection where the boundary between land and water dissolves. A massive Arthropleura slowly makes its way toward the water's edge to cool its body, each of its steps generating seismic vibrations that travel straight down into the mud below. From beneath the murky water, Proterogyrinus, the dominant predator of the swamp, does not need to see its target. It has already locked onto the centipede's position through those propagating vibrations. A confrontation between two icons of the Carboniferous erupts. On one side, the raw strength of nearly 6.5 feet of hardened chitin armor. On the other, a thunderous strike from a set of labyrinthodont jaws designed to crush bone. As Proterogyrinus bursts up from the water's surface, the collision is not merely a battle between two creatures, but an intersection of two different ecological layers. The sound of the exoskeleton shattering under the force of one of the earliest vertebrates confirms a brutal reality. In a system where all information is connected through vibrations, nowhere is truly hidden. This confrontation stands as the final proof of a world at the peak of amplification, where excess energy turns every encounter into a life-or-death struggle before the entire system enters an irreversible collapse. However, the era of giant organisms in the Carboniferous period collapsed, not due to a single cause, but because the entire climate and ecological system was fundamentally disrupted. This began with changes in the global carbon cycle, as vast swamp regions, once responsible for isolating and burying enormous amounts of carbon, gradually shrank and disappeared. As a result, the process of oxygen accumulation in the atmosphere was interrupted, while more plant material was no longer buried as before, but decomposed directly on the surface, increasing CO2 levels and reducing oxygen concentration. This triggered a negative feedback loop. As forests declined, oxygen levels continued to fall. The climate became hotter and drier, and this in turn accelerated forest collapse. Consequently, giant organisms that depended on oxygen-rich environments to sustain their respiration and large body sizes were no longer able to survive, not because they were outcompeted or preyed upon more efficiently, but because the atmospheric foundation that once sustained them had ceased to exist. The smooth functioning of this system ultimately led to a terrifying paradox: fire. In an atmosphere where oxygen made up more than 1/3 of the air, the boundary between life and combustion became as thin as a hair. A lightning strike from a tropical storm did not merely cause a normal forest fire. It triggered a biological thermite-like explosion. Fires in the Carboniferous period did not just burn, they devoured everything. With oxygen at such concentrations, even wet wood ignited violently, as if soaked in gasoline. These fires spread across entire continents, consuming exposed peat deposits and turning whole ecosystems into vast, uncontrollable furnaces. Giant organisms, slow-moving and dependent on moisture, were now confronted by a predator they could not escape. The very atmosphere that once sustained them had suddenly become the fuel that burned them alive. As the Carboniferous period drew to a close and transitioned into the Permian period, the conditions that once nurtured life began to disappear, forcing the world to restructure according to new, harsher, drier, and less tolerant rules for life forms dependent on environmental abundance. In this context, around 315 to 312 million years ago, highly adaptable organisms began to dominate, exemplified by Hylonomus, one of the earliest reptiles capable of surviving without relying entirely on water, opening a completely different evolutionary path. Following this, around several million years ago during the Permian period, organisms like Dimetrodon gradually emerged, not simply as survivors, but as a sign that the planet's biological balance had truly shifted. But is this transition truly the end, or just the beginning of an even greater catastrophe silently brewing, an event that could nearly wipe out all life on Earth? If you want to discover what happened next, tune in to the next episode, and don't forget to subscribe so you don't miss the deepest stories in this planet's history.